Hello, morning everyone. This is Satish from Danfoss. I would like first to thank you all for taking time out for attending this webinar on energy neutrality and water loss. And it's my privilege to introduce the speaker for the session, Mr. Mads Warming. Mads is Global Director for Water and Wastewater with Danfoss Drives. And he's also the Vice Chairman at the board for Danish Water Technology Association. He has been having 25 years of experience with process optimization and online control of water and supply facilities, water distribution, irrigation, water canalization system, and water treatment facilities. He has been expert for water over 25 years, and he holds a BSc degree in civil engineering. So now it's my pleasure and privilege to introduce Mads for you. Mads, it's up to you now. Yep.
Yeah, thank you, Thaddeus. And good morning and afternoon, wherever you may be. A pleasure you joined. And what I would like to talk about today is a little bit about how the global water industry is in fact looking, why it's so much in focus, but also how we have been able to move, in fact, the whole water industry to energy neutrality, and at the same time keeping the water loss down. So first of all, just a few words about who is in fact Danfoss. And Danfoss is a global group, head office in Denmark, but around about 28,000 people around the globe, and presented in more or less all countries, more than 100 countries, and production all over. If we look at the group as such, then it's doing different things, but out of the four key business areas, Wastewater Drive is one of the big ones. And what you see here on the slide is a picture of some of the facilities. The first one is from Denmark in Gråsten. There's a second one from Germany, and there's one from US. And I'll not spend too much time going in detail here, but within the Wastewater Drive, we are having VSD centers, as you can see, both in US, Denmark, Finland, China, India, and Germany. There is close to 5,000 people dealing with nothing else than Wastewater Drive each day. And within the water business, we are nowadays the largest manufacturer of Wastewater Drive for the global water industry. We are also serving and supplying, the group is supplying into the automotive industry, and that means also that the whole group comply with quality demands from that industry. But not more about Danfoss. That was just a super short introduction to who the group in fact is. But back to water and the serious issues about water. What you see here is a picture from World Economic Forum, where people meet in Davos. You probably have heard of both government people and NGOs and CEOs and so on. Meet once a year, and one of the things they are asked as participating is trying to paint a picture of what is their point of view when we look at what type of crisis or could the world potentially face within the next 10-15 years. And what they ask is basically to evaluate from 2 points of view. The one is well-being of people, and the other one is economical growth. So what could limit these things? And as you will see, there's acts on the likelihood that crisis will appear, and if it appear, what is then the impact of it? And what you will see, at least first time I saw it, a little bit surprising, that a water crisis is very high on the agenda. It's very likely that just within 10-15 years we will hit such one. and when it hit with a major impact, it's far beyond other things you can see. There's asset bubbles as a possibility. There's interstate conflicts. There's a lot of different things. I'll not mention them all, which also could happen to the world and which will have an effect. But a potential water crisis is among the 3 to 5 most likely crises and with the highest impact. Now, what is behind that, and I will talk a little bit about that, but before we do that, then I think it's very important to realize that when we talk about water, then it's not the same all over the globe. There will be places where the biggest problem is there's too much water, as we see on the top picture, and there will be places where there's no water, and there's certainly also a lot of places where the water is too dirty. It's in fact so that only 20% of all wastewater on the planet is treated right now. But if we look a little bit behind how can that be, then it's important to realize that when we normally think about water, we think about water into or supply into the cities and into our households, where water is the fundamental also for close to 50% of our food production, or all our food production, but close to 50% depend on irrigation. So if there's no water, then the farming industry will not work, and that of course will hit a lot of other industries. And the same is on the energy side, where it's claimed that around about 90% of all our energy production depend on water for cooling purpose. And there's a lot of facilities around the globe where power plants had to reduce their energy production for the simple reason that there was not water enough. What is also the case is that water is over abstracted already. A lot of places around the globe. We have California as a case. We have southern part of Europe as a case. We know there's places in both India and China and other places where groundwater is used for much faster than nature is able to regenerate it. So that's where we are now. If we look 20, 30 years out, then we all know that the population will increase. We also know, which basically is a very good thing, that more people will move out of poverty and into the middle class. And we also know that more people will move into cities. It's expected within 20, 30 years that 70% of the people on the planet will be living in cities. Now, that put, of course, pressure on that we need more food, we need more energy, and at the same time, there's other things which influence the water consumption. One of the things is that one can say, why does it mean something that people move into the middle class? And the only reason for that is, in fact, that behind that is that then the type of food which are consumed tend to change, and that is to a type of food which consumes a lot more water. The end of this story is that it's expected within the next 20 years that we need 40% more water than what we are using today, and that on a basic where we already are overdrafting the water resources we have. So saving on water and finding solutions to that is a key thing. So that's why water is so high on the agenda around the globe. What a lot of people maybe is also not aware of is that the water industry not only is super important for the food industry and for the power generation industry, but also in itself is a major energy consumer. We, Danfoss, have worked together with International Energy Agency a couple of times, first time back in 2016 related to the water industry. And they made a global survey and estimation on how much energy is the water industry in fact consuming. and came to a conclusion that around about 4% of all electricity on the planet are used by the water industry. This is equivalent to all the electricity used in Russia. What is maybe as interesting is that 30–50% of the electricity built by municipalities is related to the water industry. And in 2018, they have then looked at also the Sustainable Development Goals, and without digging too deep into it, what is as part of that is to build a lot more wastewater facilities. And if we comply to these goals to 2030, then you could build it the traditional way, traditional wastewater facilities, and you could also build what I will tell something about wastewater facilities, which in fact are able not only to clean wastewater but also to generate electricity at the same time. And the difference between these two things they have looked at and came to that was close to 600 terawatt hour, and to put that into terms to possible to understand, that is an energy volume which is equivalent to that you could close all coal-fired power plants in Europe. So this means something. And finally, as introduction, also a little bit from Canada, just splitting a little bit more down in what in the authority electricity is used for. And as you clearly can see here, the water and wastewater facilities are the high runners. And there's also made a comparison here to street lights, where it shows that water and wastewater facilities use 6 times more energy than street lights. So, looking at water and wastewater facility, why are there so much to gain by using a lot more smart process control? And the very basic reason is that if you had a food or chemical facility, then you probably would start 6 o'clock in the morning and close down maybe, what do I know, 4 o'clock in the afternoon, or if you run 24-hour, then you would run pretty stable or at 70–80% of the load. If you look at the water industry, then as we all know, then it's fluctuating up and down, and we know we have 10–20% load during nighttime, and then a peak in the morning and in the afternoon, and we know we are running 24/7 and 365 days. So it is an industry where the water industry, where whether we like it or not, the fluctuation is very high, and that means that if you don't have a system which automatically can adapt to these fluctuations, then you will use far too much energy and chemicals and other things. So that's why we see that when we have facilities where they really try to go to the full extent of what is possible, what nowadays is called digitalization, then we see major results, and I'll come back and explain about these. If we look at the whole water cycle and look at what they have done in the case I will refer to here, then they have had a 2-tier strategy when they want to reduce the net energy consumption. The one has been to secure that you reduce energy consumption as much as possible during all the phases. So if you look at water production, they have cut down on the water production or the energy cost in relation to providing raw water. They have made major cuts on water distribution, and we'll come back and talk a little bit about that. They have also been able to cut the energy consumption on wastewater pumping, as well as on the wastewater facility. And what is important at the wastewater facility is that if you do it right there, which we also will come back to, then you will be able also to generate lots more energy. And that means that all the red ones can be included in in the green one, and therefore suddenly you have a situation where you can provide both drinking water, pump the wastewater, and treat the wastewater basically without using energy, just by being super efficient on the energy side, saving, and at the same time increasing your energy production. To do that, of course, it's important with high efficient components, and I'll come back to also it's important that there is a controllability, and that is what variable speed drives will be able to offer. Talking about that and talking about variable speed drives, then normally it's considered that variable speed drive have a 2% loss when you install them, or 98% efficiency, which in general is also true. There is deviations, but what quite often is forgotten is that it is important to look at installed efficiency instead of looking at the efficiency of the drive itself. And when we say installed efficiency, then what we're thinking about is also how to get rid of the air or the heat, which the variable speed drive generates. And we have a special solution with a back channel cooling where we can take 90% of the heat out, basically without using energy. And the other thing, which is also pretty energy consuming, is harmonic mitigation. And where on the one hand, harmonic mitigation is important, but don't use it more than necessary, because it will consume a lot of energy. And the other thing is that if you look at harmonic mitigation, then you can choose different technologies, and Danfoss offer all these technologies. But some of them, and especially for the water industry, the advanced active filter technology will do the same job or better job, in fact, than traditional active front end, but will just do it to a lot less, or do it by using a lot less energy. Again, without deep diving too much into this, then the results of this is, in fact, that you will see that by choosing one variable speed drive supplier versus another one, you can see 2 to 4% difference in installed efficiency. And that basically you can compare to that you could also choose to step up in the motor efficiency, but that would only offer you around about 1% in gain. So in fact, instead of stepping from a IE2 to IE3 motor, you would be able to gain maybe 2 or 3 times more energy savings by choosing the right variable speed drive solution, which of course from our side is the Danfoss solution, where we have these opportunities both on the heat side and on the harmonic mitigation side. Coming back to the process part of it, so this was just mentioned here a little bit about how it's important to have efficient components. But on the process side, then we know that when we are supplying water into the network, we know that we see leakage there, and they can be quite expensive to repair and handle. What you see here is a few pictures, and you see also some figures which are indicated in percentage what the non-revenue water is. So it's fluctuating from down from 4 or 5% and the whole way up to 50 or 60 or even 80% I have heard about. So leakage is a main issue. In US, it's claimed that there's 850 main water breaks each day. So it is a real issue. What then to do about it, or what type of leakage do we have? And I think it's important to realize that there is what we call background leakage, and that is in joints and so on, where you will have a small leakage going on in the underground, not visible. There will be cracks in the pipes, which again is not visible. They are not large enough that they will just the water will just run out down in the ground. And finally, we will also have the type of leakage where the water is coming to surface, as we just saw on the previous pictures. Now, what is interesting is that when you have when you have to do something about it and you look at the tools you can use, then pressure stabilization and pressure reduction is in fact the tool you can use both to attack all three of them. Of course, the last one here, where it's coming to a surface, one have to repair the pipes, no doubt, but else pressure stabilization and pressure reduction will be a key thing. And quite often, it's thought that these major bursts, where you see water flying, what do I know, 5-10 meters up in the air, that is where the main water loss is. And the facts have shown that life is quite different. And the reason is that these major water loss or bursts typical are controlled within 3, 4, 5 hours. There's coming a lot of water out, but it's a short time span where it's happening. And measurements done, this is then a case from New Zealand, have in fact shown that less than 20% of the yearly water loss is coming from these main bursts, whereas 80% is coming from what is invisible, also the two others we spoke about, the background leakage and unreported leaks. And the reason for that is that these leaks are running 24/7 and 365 days a year. And therefore, really to get leakage down, it is important to look at pressure management. And then coming to in fact, what can you do about leakage? Yeah, you can do pressure management, as we have touched on, and you can do what is called active leakage control, which basically is to replace pipes. But nobody can usually afford to replace all the pipes, so it don't make sense. And as we also just have seen, that if you want to attack the 80%, then pressure management is the cheapest way to attack that. And what do we then mean when we say pressure management, and what is the thinking behind it? If you look here and imagine we have a city with a couple of buildings here, high rises, and we assume that we want to have 20 meters of pressure on the taps in these buildings, then we would need a pressure as integrated here, or indicated here with a green line. If we then have one single pump at the waterwork, and we also have a small hill here where maybe there is a few people living, then you would have to ask this pump here to put the pressure the whole way up to what is here stated as original hydraulic grade line. And you will have some pressure loss, and then you will see that also the people living on the hill here have their 20 meters of pressure. The people living in the city here also have their 20 meter. In fact, they have probably 60 or 80 meters of pressure. So they have a lot more pressure than in fact they need. And besides that is consuming a tremendous lot of energy, then it's also stressing the pipes. So what to do about it? One thing is or the solution could be to install what we call a boosting pumping station, basically a drive and a pump and a pressure transmitter. And that means that the pump here at the waterwork only take it halfway now to optimize hydraulic grade. And then there will be some water the losses. And then we have the boosting pumping station taking it up. And then again, the guy living on the hill here will have his pressure. And so you can keep going, splitting your cities or network into pressure zones. I got it right, then London is split into around about 800 pressure zones, just to give you a feel. And the more you split, the more you will take the pressure down, and the more you will be saving on both energy and stress on pipes and leaks, and which we'll come a little bit back to. This is a picture from Australia, where you can see you have a timeline down here, and you have also what they call main breaks and service breaks. The dark blue is main breaks, and you can see the amount of breaks they had before pressure management, and then they made a pressure management where they achieved around about 30% reduction, and you can see how the amount of new breaks in the network is dramatic dropping. We are talking more than 50%. This is a little bit from US, a case where they were pretty sure that they were in control of the pressure, and it showed that that there was a lot of spikes when they begin to measure the pressure real time in the network. So again, I will not deep dive too much into it, but also again, one thing is to get the pressure down, and another thing is to avoid these pressure spikes as you see them here. This is a little bit interesting because we all know that the water network is different from city to city, so therefore it's also difficult to come with a single conclusion and say this is just what everybody have to do. But the basic we can say something about, because this is an overview of statistic on 112 systems in 10 different countries where they have tried to do pressure management. And what they gained in average was a 38% reduction in pressure, which offered them a more than 50% drop in the amount of new breaks. It also immediately, when they installed this pressure management, and that was basically without replacing any pipes, they were able to cut their water leakage with close to 40%. And energy consumption also dropped with 20 to 40%. And then, of course, the pipes will most likely last longer, and there will be less complaints from the people in the city. So I think this is quite impressive that you can gain so much without replacing pipes, just by going in and regulating the pressure. So that was a little bit on water distribution. Then on wastewater pumping, usually the thinking is that there is not so much to do because it's typical gravity forced. So the water is basically running just based on gravity, and then it's lifted in a pumping station. And one can say, what can you do to save energy there? And one of the things one can do, which we have embedded in our Aqua Drive as a standard, is to do what we call deragging, and what basically that is a function which will secure that wastewater pumps have a tendency, especially in the sewage canalization system, to clog over time. And one way to avoid this is to have the drive to measure on the power consumption at a given speed. And when then the power consumption go up at a given speed, then it's in 98% of the cases will be because of clogging of the pump. And what the drive then will do is that, or the variable speed drive will do, is that it will turn the wheels in the pump the opposite way. And in that way, in fact, it will not only turn it, it will start on running a little bit forth and back, and in that way it will in fact make a type of washing of the pump, and so getting rid of all the dirty stuff clogged in the pump. And that have two benefits. The one is that it have the benefit that the maintenance interval, or the intervals when people need to go out and look at the pump and clean it, will be extended quite dramatic, have we seen in a lot of cases. And the other one, and important when we talk energy, is that the energy efficiency of that pump will be kept on a high level. Whereas if you accept that it's clogging, then of course the efficiency is going down when it clogs more and more. And finally, to the wastewater facility, there is a lot to do, and there is a lot of processes one could go into. Before we do that, I would like to show you, in fact, the figures. This is then a case from Denmark for 200,000 people, where you both have the drinking water network and you have the wastewater facility. If you look at the figures here, then you will see that they have used 3.2 million kilowatts on providing drinking water, 0.8 million kilowatts on pumping wastewater, and to treat it, and you can see the figures here to what level the wastewater is treated, 3.2. So in all for the water cycle as such, for these 200,000 people, used 7.2 million kilowatts per year. They have been able to get 4.8 million kilowatts in electricity production and 2.6 in heat, which they are then in surplus heat, which they are then using in the district heating system, and offering them 7.4 million kilowatts. And that means that in fact they are producing more energy than they need, both for providing drinking water, pumping wastewater, and treating the wastewater. If you look at the treatment facility, the wastewater facility itself, then it's producing 234% energy, and that means 134% more energy than it needs for treating the wastewater. So we are not only talking about energy neutral wastewater, we are talking about that it's producing the double amount of energy, which is in fact is needed for cleaning the wastewater. If we only look at electricity, which could be relevant some places because they cannot utilize the heat production, then we are at 150%. And for the whole catchment area, we are in balance, as mentioned. That means that producing a little bit more electricity or energy than is needed both for drinking water and wastewater. So quite impressive, and especially impressive because it is on an existing wastewater facility. You can see the picture of it here. It's a standard old, by the way, very old wastewater facility activated sludge treatment plant. So there's nothing special or fancy about it, besides that there's a tremendous lot of sensors and tremendous lot of multiple speed drives. So if we look at what was the key in this, then what have they done? A tremendous lot of sensors have been installed there, and in fact sensors which you normally would not or would doubt whether you could use or not, and they have found, based on some software, a way to get reliable signals from these sensors. Then what we of course like is that they have variable speed drives on whatever can rotate, so all motors they have variable speed drive on. They are thinking different at wastewater and thinking of that the wastewater is a source, not a problem, but a source of energy and other things coming in. So they are looking at how they can harvest as much as possible carbon in the first phase to get as much as possible for their digester. High efficient components we have touched on. One of the process points they have used is that they are removing ammonium, and in that part they are using a simultaneous nitrification process, which is controlled on ammonium and nitrate sensors and basically not on oxygen. And the consequence of that is that you will see that your oxygen concentration is super low, and that is also creating a situation where you have a very, very low oxygen concentration, and that means that your efficiency on your aeration system is going up and improving then the efficiency quite dramatic. They are also using side stream anemox, which again have a side stream. That means from your sludge dewatering, the water you get there, the reject water you get there. And what it basically is a process where you will be able to treat the very high ammonium concentration with a lot less energy and with using less carbon, and that means basically you have more carbon for your digester again. And what they also are doing is partly active nitrate shunt, and that is coming back as part of it back to the low DO concentration that the type of bacteria culture they will have there. Means that they will part of it will be handled by the nitrate shunt, and what that means is that again you will save energy and you will use less carbon, and that means that you have more carbon for energy production. So you will see the concept in a lot of this is that you on the one hand on the wastewater can save energy, and at the same time you will get more slots of carbon for your digester, and not only you're saving energy, but you're increasing your energy production, and that is in fact the trigger behind some of this. I think this is pretty important. If we should summary on some of the things I have said here, then both the water loss side and the energy neutrality I have been talking about basically come down to using a lot more real-time sensors, which are relied on so much that you let a computer system control it. You need controllability, which is basically what the variable speed drive is offering, so that you can regulate both on pumps and on blowers, on mixers, and what do I know. You of course need to understand the process in deep and have a process control. But if you visit the facility, you would see that it's not a super big system. It's done pretty simple, but knowing exactly what to do. What is key message here is in fact that if they look at where they have gained the improvements, and we have other facilities coming with the same statement, then the claim is that 70% of all the improvement they have gained is coming from process control or digitalization, as it's called. So the sensors and the variable speed drive is in fact the ones who, together with process control, which have offered 70% of the savings, whereas 30% is coming from more efficient components, as for instance high-speed turbo blowers and so on. So that is basically the trend in the industry to use a lot more sensors and a lot more variable speed drive combined with more SCADA systems or process control system, which by the way will also be interconnected. And the other thing which I touched a little bit on is that the components, and especially variable speed drives, are getting a lot more intelligent and advanced. And we were touching on this just as a case feature that you can automatically clean pumps based on this deragging function in the drive. And finally, the facility I just have mentioned for you have in fact been in a sustainable report for Europe, being highlighted as a prime case in whole Europe. And it is, to my best knowledge, also the first place on the planet where you have an energy neutral both drinking water and wastewater treatment. And that have also made some noise around the globe. We have got a couple of awards from different countries. I will not deep dive into that. So I think that was the words.